Perfect. So yeah, my questions would be basically on the research paper. I was going through that, and in the paper, the very first question would be on the coordination advantage. So in the paper, you mentioned that WND avoids the repetition issues found in multi-agent or orchestration because all tools share the same reasoning context. So does this suggest that the single brain many hands approach in inherently I mean it is superior to the agent swarm like Kimi K2.5 for complex research purposes?
Okay, maybe I will begin from my side. So I wouldn't say that it definitely outperformed like Agent Swarm, and to what I'm thinking, probably these two should be compatible. Like I don't know. Like I have no idea. Because right now we are trying to understand, because most of the current proprietary model they are equipped with like this parallel to calling. So
Mhm.
what we did is that as compared to much complicated multi-agent system, we were thinking that like how far can we go with a single agent, and then like with the current parallel to calling, like how well can it do? That was the primary purpose for what we started this research project. Yeah, and then so we were not trying to claim that it will definitely outperform the multi-agent system, or maybe it could be compatible. I have no idea. But as for now, what we were thinking that what we found to be surprising is that even like a single agent, if for a certain tasks such as like this kind of like information seeking task, this parallel to call capability does help it to actually gather information much more effectively. So it seems like showing some kind of gain similar similarly observed in like Agent Swarm in Kimi K 2.5 as well. Yeah, just that we are approaching from a slightly different direction. Yeah.
Got it.
What we did last time is we do trying to test most of these either closed source or open source model with like parallel to core capabilities. Like we
Mhm.
tested a couple of those like Cloud, Gemini and GPT. And for open source, I think we tested what did we test again? I think DeepSeek, right? And
DeepSeek and Queen.
Right.
and
Yeah.
Queen, yeah. So we tested and we actually made pretty similar observation. But what we probably found is that these open source models are still lagging behind a bit, but the overall observation is still pretty much similar. That parallel to calling does increase the efficiency. Yeah. So I mean, if there are more models to be equipped with this, and if it's yeah, we could definitely try that and then see whether it generalized. But on, I think in general we do observe like similar observation across all models with the parallel to core capability.
Got it.
But
Got it.
just to add some context. So when we mention the like the benefit of parallel to calling is to repeat, is to avoid repetition in the reasoning, right? When we say
Yeah.
this, we are discussing this in the context of parallel reasoning. So there are some work that do parallel reasoning where
Mhm.
you make 10 LM calls simultaneously using the same prompt. And by doing that, you get 10 different reasoning trajectory and 10 different tool calls. And for this case, sometimes you may find some of the response to be similar, like maybe two reasoning, they are very similar and they generate very similar tool calls. So in that case, because each call, they are independent from each other, so they are not aware of um, other generations. Like let's say you make
Mhm.
10 generations, one generation is independent from other 9 generations. But when you do parallel to calling, the LM will do one single reasoning and it will incorporate what is already called, right? Let's say you ask the LM to generate 10 tool calls simultaneously, it
Mhm.
will take into consideration the fact that some tool calls are already made. So for the rest of the tool calls, it should be different from what's already there. So by doing this, it will reduce the repetition in the reasoning as well as the
Mhm.
repetition in the tool calls.
Got it. Makes sense. My next question is on the on source credibility. So you found that parallel calling, as you mentioned, Xiao, that it improves accuracy by allowing the model to compare multiple sources simultaneously. So have you observed any majority vote hallucinations where if three parallel tools return the same wrong answer, the agent becomes more confident in the error than a sequential agent would be?
Um, okay, let me see if I understand your question. So you're asking if, let's say, the parallel 2 calling, some of the parallel 2 call, both of these answers are incorrect, with the model being biased towards the wrong answer. Is that what you meant?
I'm sorry, you were breaking off a little, Arjun. Can you repeat that?
Oh, sorry. I think my internet connection is a bit bad here. So I was asking, like, if your question is that, so if a model is making parallel 2 calling, but some of the parallel 2 calls answer are wrong, and then will the model being biased towards the wrong answer, being more confident towards the wrong one? Is that what you?
Right,
Oh,
right. As
hmm.
compared to the sequential agent would.
That's a good question. Frankly speaking, what we observed earlier is that there seems to be some kinds of, like, for example, mismatches between answers. So, for example, one of these two call, I mean, if they were wrong, but probably they were wrong in a different way. So the model can tell, like, the answer seems to be a bit inconsistent. So probably there's something wrong with the current like search or
Mhm.
browsing outputs. So the model might require another round of tool calling to double check whether there are more trustworthy sources to actually you can trust from. But on the other hand, if you are doing in a sequential manner, very likely it will fall into like a local optimum and keep on following the wrong track. Yeah, but unfortunately we don't really like sort of like having a very solid experiment to actually compare this or like quantitatively evaluate this. But at least from some of the example cases that we observed earlier, having this kind of parallel to calling does help to eliminate like those cases with like very inconsistent observations. At least they know, at least the model can know, like, probably this is something wrong with the information sources that being obtained. Maybe we should search again or do other stuff.
Right.
Yeah, when we say the comparing from multiple sources, we are comparing the case that you do the single tool call, right? In that case, you only have one tool call and one response, and if the
Mhm.
response is wrong, the model will take as it is, right? So in the worst case, in our parallel tool calling, all the tools return wrong answer. It will return to the same bad case as you have one single tool call. So it's generally better than single tool call because you have verifications, you have multiple source to choose from, right?
Makes sense. Yeah. I think that's actually better. That's true. Um, my next question is on the descending scheduler. The explore early, exploit later strategy. It was mentioned in the paper that it gave a 6% gain. So do you think this is an universal law for AI agents similar to simulated annealing in physics, or is this specific to web browsing tasks where the search space is infinite, of course?
That's also a very good question. First of all, we have to clarify that because this descending scheduler is not trained before, because we are just calling API to and enforce it to um make more calls in the beginning and slightly less call towards the end. But actually, this model is not trained under this setting, so we can't say that actually this is something that is generally useful for across all models as well. This is one thing. we have to clarify beforehand. And the other thing is that whether this is something universal for across all tasks, or whether it's mainly useful for web browsing tasks. So this is also another thing we have been thinking about, because parallel to calling, or maybe even like multi-agent system, maybe at least for parallel to calling, when we are doing this project, what we thought is that it seems to be especially useful for like information seeking like tasks. But because for other tasks, let's say if you have like other tools of like I don't know, like maybe doing some calculation or doing some coding, could be useful in a sense, uh but I mean, probably browsing or searching seems to be the one that benefit the most, because there are so many possible sources out there, and then what you can do include like verification of different sources to see whether the results are consistent, or maybe it can for example, like some of the tasks in the browse.com benchmark, we can see usually the question have a lot of like different hints, but you have no idea where to start from. So this kind of parallel to calling enable the model or the agent to actually sort of like branch out to look for a lot of different hints, and then gather more information. Then at least you know where to where are the overlapping hints that you can continue searching for. So so all these things make me think that probably other tasks could be useful, but seems like web searching itself is the one that is particularly makes most benefit from it. Yeah, and for the descending scheduler wise, yeah, like what I say, because it's not trained before. So but from what we observe, seems like it's also useful in a sense for this web browsing task. But for other tasks, it is a bit hard to say, unfortunately. Yeah. Yeah, Xiaoqiang, you got something to add on?
Yeah, so
Yeah.
I agree with that. But I have something to add on. I feel that for tasks that require more like newer information, you will generally benefit from it, because think about the language model, that large language model, they already have some knowledge about the word, right? They have some information about the word. And if you ask a question that is very niche, and the answer is not very intuitive, the model may answer it wrong directly, because it will rely on its internal knowledge first, and then it might like goes to this wrong direction, where it relies on its internal knowledge and try to validate this internal knowledge. For example, one question that we encountered earlier is the question about a Grammy award, like who get the most Grammy award for a certain subcategory, and the model has some knowledge about this. So obviously, Taylor Swift is one of the most frequent winner for the Grammy award, and we figure out that for the single agent, it will constantly verify that whether Taylor Swift is the best the singer that would win the most Grammy award. But if you do wide research, like searching a lot of information initially, the model will try to explore more information or newer information on the internet before it falls back to its instinct or internal knowledge. So if you have tasks that require newer information, or require some niche information in the internet that is different from the internal knowledge of the language model, maybe doing wide research in the early stage, and then doing deep research in the later stage, you will generally benefit. But that's my assumption. We didn't find a way to verify that, but that's one case that we have found during our experiments.
Got it. I mean, this might be an off-topic question, but I actually was recently reading an article on event-driven agentic AIs. There was this article by Sean Falconer. He mentioned that how the future of AI agents is event-driven. And I kind of, I mean, I'm not a practitioner. I do not have a tech background, so, but still, I saw some similarities. So your parallel tool calling setup feels very similar to an uh, event-driven execution model with the fan out, fan in, and asynchronous tool responses. So, do you see this as a form of event-driven architecture for agentic systems, or do you frame it differently?
Uh, Frankly speaking, I'm not that familiar with the event-driven agents.
I understand. Yeah,
Yeah.
yeah.
So
Don't worry about it. It was just a thought that was on top of my mind. I thought I'll just ask you if you had any ideas behind it. I mean, was it related to it or not?
I see. I see. Thanks for bringing that out. Yeah. Maybe
Yeah.
we can go through that later and then
Mhm.
see. Yeah.
Sure, sure, sure. My next question would be on the open source versus proprietary. So basically, you noted that Quen and DeepSeek didn't see the same massive gains from parallel calling as GPT-5 or Claude did. So is this a training gap in how these models handle multiple tool call tokens? And what should open source developers do differently to catch up? I mean, what are the gaps according to you?
Hmm.
Probably the data that those closed source model have, right? Because we feel that for those open source model, they
Mhm.
they are not very good at doing parallel tool calling, and that's probably because in their training data they don't have um, a lot of data that teach them how to do parallel tool calling, and so I feel that there's a need to create such data to make up for that. And
Mhm.
yeah, but we are not sure about like how they train on their model, because these data are not open sourced, and those they are not fully open sourced. So this is just an assumption we have.
Yeah. I kind of agree. Probably data is the main reason that it's still lagging behind those proprietary models. Yeah. But if you're asking how to improve it, yeah, this is something still unknown to us as well. Yeah.
Mhm. Okay. And certain challenges, like the paper shows that LLMs still can't autonomously decide the optimal number of tool calls.
Mm.
Um, the automatic strategy performed worse than your manual descending one. So, is the next frontier RL specifically for width management?
Sorry, what's your last question again? I didn't get it.
I mean, what do you think about the next frontier? Is it
Oh,
reinforcement learning specifically for the width management?
oh, mm, yeah,
Possible,
yeah.
but we
I
don't
think,
know. That's
yeah,
the short answer.
It's it might
yeah.
be,
Could
yeah.
be. I mean, yeah, because this thing itself is pretty dynamic, completely decided by the RM. So kind of like I think a bit hard to say is there a universal way to decide it. I think also kind of similar to the Kimi K 2.5 agent swarm. So the number of like sub agents being called is also dynamically decided by the orchestrator. So I think similar case for us, which we have no idea or no prior knowledge like for each subtask how many tool call or the ground truth number of tool calls is not known beforehand as well. Yeah. So yeah, also kind of like very hard to optimize. Yeah.
Okay.
Yeah, it's really dependent on the task, right? Um,
Mm,
so think about using a single agent to solve a task. You roll out the agent for a few hundred steps, and the main so the way to, I feel that one way to decide the width of each step is that if you don't do parallel to call, meaning that everything is sequential, and you look at the trace and see how much each steps can be parallelized. So let's say you have 5 steps, 5 sequential steps, and they seems to be not dependent on each other, meaning that at the step 1, you could have made 5 steps simultaneously without having the new information. So if that's a case, then the model should have done this wide parallel to calling in the first step, right? So it's really the model have to be not be myopic about what's coming next, right? It has to be forecasting what will happen in the next 10 steps to be able to know how to plan well at the current step.
Got it.
Yes, there's definitely rooms to improve the model to do that.
Makes sense. My next question would be on, I'm probably the last one. So it's on context management. I mean, as you scale the width, you're dumping a massive amount of tool output in the context window at once. How do you prevent the lost in the middle problem when an agent receives 5 different search results in a single turn?
The short answer is that we didn't prevent that, because we didn't do context management in our case.
Okay.
For example, for single agent, maybe you will do 5 steps sequentially.
Mhm.
For our case, we do these 5 steps in one shot, right? So compared to this one single step, we actually have the same context in the LLM, right? So we just make the trace shorter, but the width is larger, right? So the context actually does not increase for solving this specific task, because you shorten the number of iterations that is needed, but at the same time you increase the width. So the total number of tool execution is probably very similar, or slightly larger. So we don't do any specific stuff in preventing loss in the middle. Yeah, but that's an interesting feature direction to think about.
Yeah, I think because we have seen so many context management techniques nowadays, like those adopted by either DeepSeek and then as well as like a lot of like anthropic models as well. So I think very likely this parallel to calling is compatible with those as well. Like if we are making very long, because right now what we observe is that having this parallel to call indeed shorten the number of iterations, but still if we want to make it extremely long, the trajectory, so how to manage those two core, for example, like dumping some of the earlier two core results or having some summarized two core outputs could be a way to go with it, and I believe these are, compatible.
Okay. And I mean, that's all from my end in terms of the questions. Just one very broad question, and feel free to cover the privacy or the things that you can't share. But sorry. So, what are your plans with this? I mean, what are you guys currently at a stage where you have published this paper? What do you guys have in mind in future? What are you guys doing with this?
Yeah, frankly speaking, because this project just ended not long ago, so indeed internally we are still discussing like how to continue with this. Frankly speaking, we don't even have a solid idea, even our own. Yes, yeah. So so we are still doing some kind of brainstorming, seeing like which direction should we focus on next, and how should we continue doing along with this. Yes, yeah.
Right. Makes sense.
Yeah.
Yeah. I mean, I think
So-
it's too soon
so-
to ask you this because since it was it is your
Sorry.
publication. Sorry, Xiao, you were saying something?
Yeah, I just want to mention that we want to use this work to that the community be aware of this area, so that they can they can keep working on this line of work, because this direction is underexploited in our opinion. So just welcome any like follow up in the community for future directions.
Right.